Good evening, Titans. This is Mr. Sturts, and we are now on lesson 6.4, which is covering exponential growth and decay. So if you would, open up your student journal to page 185, write down these three vocabulary words. We're going to be talking about growth, decay, and compounding interest. So let's start with exponential growth functions. We have our formula right here. It's actually written for you in your student journals. Okay, but we need to know what each variable stands for. We have y, which is our final amount, what we end with. A is going to be our initial amount, so what we start with. What's in parentheses there is what we call the growth factor. And we have our rate of growth, which is always in decimal form. That's our variable r, and then t is our variable for time. So we have a little word problem here. The inaugural attendance, so the first year of an annual music festival, so held every year, is 150,000. The attendance y increases by 8% each year. So what they want us to do is they want us to use our formula, and we need to write an exponential growth function because it says it increases by 8% each year, so we know it's growth. That represents the attendance after t years, so we don't know the years, so we're just going to leave that as variable t. So we're going to go ahead and write our function. We said y is our final amount. We don't know that yet. But what they do give us is they give us our initial amount, which is 150,000 people. And if we're using our formula, we said it was growth, so we're going to use our 1 plus our growth rate, which they gave us 8%, so that's going to end up being 0.08. And raised to t, we don't know years, we said, so we're leaving it as t. Okay, and then part B says how many people will attend the festival in the 5th year. So here they actually give us what t is. They give us, we need the 5th year. Now something important to remember for this example is that t isn't 5. Okay, it's easy to think it's 5, but if we think about the inaugural year, which means the first year, t was actually 0 in that first year. So what we actually are going to use for our time is a 4. Okay, so if we solve this out, we have y equals, everything stays the same. 150,000, that's our initial amount. If we just go ahead and add what's in parentheses there, we're going to get 1.08. And t is going to be 4. If we do our exponent there, and we solve it all the way out, remember exponents first, then we multiply. What we're going to get in the end here is 204,073 people. So using that growth function, we figured out that in the 5th year of the festival, with our growth rate, they're going to end up with 204,073 people. All right, now switching gears to exponential decay. Okay, the big difference between growth and decay is when we look in the parentheses, if that value is greater than 1, we're going to have exponential growth. If it's between 0 and 1, we're going to have exponential decay. And we'll see that in examples as we go forward. Everything else stays the same in the formula. So we're going to look at these two here. These two graphs, so we got to figure out if they're growth or decay. If we notice our x's, we always increase by 1. Okay, but what we're really focused about is as the x increases, what does y do? Here it's actually decreasing by, well, it looks like we're actually dividing by 3, which is the same as multiplying by 1/3. Okay, dividing by 3, multiplying by 0.33 essentially. So this is between 0 and 1, our growth or our decay factor actually here. So we know this is going to be decay. Okay, as x increases, y is decreasing. Now in part B, x is increasing, y is also increasing. Okay, and that's increasing, we're multiplying by 2 each time. Okay, again, that's greater than 0, that's greater than 1, so we know that's going to be exponential growth. And it's exponential again because we're going up by a ratio. We're multiplying or dividing by a number each time. All right, let's get into a couple examples here. We need to determine whether it's growth or decay. Again, we look at in between the parentheses there, we see that number is greater than 1, 1.07. So right away we know that's going to be exponential growth. Okay, it's greater than 1, so we see exponential growth. Now the second part says identify the percent rate of change. So what we're trying to find is that little r in our formula. If we know in our growth function, in the little parentheses in our formula we have 1 plus r. So we got to figure out what r is. So if 1 plus r equals our 1.07, Okay, and we can ignore the parentheses there, they don't really matter, but to solve for r, we can subtract 1 from both sides, and we get r to be 0.07. Okay, now let's look at the right one. In between the parentheses there, it's less than 1, it's between 0 and 1, so we know that is decay. It's going to be exponential decay. Now we got to solve for r again. In our decay function, we have 1 minus r equals that factor. So if we have 0.98 is equal to 1 minus r, and we're going to solve for r, think back to earlier chapters, let's first add r to both sides. Okay, so we have r plus 0.98 equals 1. Now to solve for r, we're going to subtract 0.98 from both sides, and we're going to get our r to equal 0.02. Okay, and that's how we're finding our percent rate of change. All right, now we need to rewrite each function. Now this is a little higher level thinking. Using the properties we've talked about, we're going to actually use the power of power property first. We need to rewrite this to figure out if it's exponential growth or decay. Looking at both of these, we can initially assume that part A is exponential decay, but if we notice, it's not in that exact form that we're using. We have this little t divided by 4 up here as our exponent, so let's rewrite it. Okay, so really what we have is 100 times 0.96 raised to the 1/4 times t power. T over 4 is the same as 1/4 times t. So if we use our power of a power property, let's keep the t on the outside to get it in our formula. We're going to rewrite this as 0.96 raised to the 1/4 power times t. Okay, now we need to do the math there. Actually, if you type that in your calculator, you're going to get 100 in parentheses. It turns out to be 0.99 if we raise it to that 1/4 power to the t power. Okay, and what we actually we can see there now is it's less than 1, so this is actually exponential decay. All right, and let's look at that part B there. Now, if we think back to division, when we're dividing exponents, we said when we're dividing like bases, we subtract exponents. So if we rewrite this, another way we could rewrite this is 1.1 raised to the t power over 1.1 raised to the 3rd power. Okay, think back to last section. When we rewrote that, like bases, we're going to subtract exponents, so these two things are equal. Now, if we go ahead and solve this, if we want everything in the numerator, we could rewrite it as 1.1 to the negative 3rd power to move it to the top times 1.1 to the t power. Now we're close to our formula. Now if we solve that, put that in our calculator, 1.1 to the negative 3rd power, we're going to end up getting 0.75 times 1.1 to the t power. Now we see in parentheses it's greater than 1, so we see that that is going to be exponential growth. So that's using our properties, rewriting it. A little higher level thinking, but we're still using our properties to see that that's growth, and that first one was decay. All right, last thing here, we're talking about compounding interest. All right, and this is actually a real-life application using our exponential growth functions. This happens at the bank a lot. We might not be familiar with it quite yet, but in the future you will become familiar with it. It's when the interest earned on the principal and on previously earned interest. Okay, it's kind of building over time. So we have, again, a formula, but we need to know what our variables stand for. Principal, that's what our variable P is. That's the initial amount. That's our starting amount. R, again, it's still in decimal form, always in decimal form. But that's our annual interest rate. Okay, so that's how much it's kind of growing by each time. T is, again, time in years, and N is the new thing. It's the number of times interest is compounded each year. Okay, so if it said annually, that'd be once a year. If it was compounded 3 times a year, we'd plug in 3 for N. All right, let's do one example using that idea, compounding interest. So we're going to use our formula again. Okay, as a reminder, our formula y equals P, which is our principal, 1 plus our rate over N, which is times compounded in a year. And we're going to raise it to the times compounded in a year multiplied by the total time. Okay, and now let's plug things in. We deposited $100, so that's our initial amount, that's our principal. In parentheses, 1 always stays 1. It's not a variable. Okay, that's our constant. That always stays as a 1. Our rate of change, it says 6% annual interest. So our rate of change is going to be 0.06. If we change that to decimal form, always change that to decimal. Don't plug in 6. Okay, it's going to change our answer completely. Now it says it's compounded monthly. Okay, so we got to think how many months are in a year. Well, there are 12 months in a year. So that 12, that's going to be our N. Now we got to raise it to the n times t power n is still 12. Okay, that's monthly. And then t, after t years, they don't give us what t is. It just says after t years, so we're going to leave that as a t. Okay, and then for now, we'll just simplify it as far as we can go. We don't have t, so we can't actually solve and get an actual number. Okay, but if we went ahead and kept solving this, we get 100. Now in the parentheses, if we do the math there, we're going to get 1.005 raised to the 12t power. And again, we can't solve it any farther. We don't know what t is, so that's going to be our answer. Okay, if they said after 20 years, we just plug in 20 for t, and that'd be our answer. All right, now that you're done with the notes, please turn to page 187 in your journal. Again, attempt these 4 problems. Okay, this will kind of tell you where you're at with this video, and then we'll go over them in class tomorrow. Thank you for watching. Have a great night.